Alright, so the question says that this object is in static equilibrium. Now they're asking us to find tension 1. They're asking us to find tension 1, tension 2, and tension 3. They're also asking us to find the angle theta. And if you can see, this object that's attached to this has a weight of 40 newtons, and then this one has a weight of 50 newtons. Now, how can we find tension 1, tension 2, tension 3, and the angle theta here? So we are going through solution first. So we are going to resolve this into the x component and the y component. We're also going to resolve this into the x component and the y component. So how do we go about it? So let me just redraw it again. Yes, so I have redrawn the object. Now let's resolve this into the x component and the y component. As you can see, the angle theta is here, so we are going to resolve this into the x component. We are going to resolve tension 3 into the x component and the y component, right? So this, since the angle is this side, this part, the part that's not carrying an angle, will be T3 sine theta. If this theta was here, this would have been T3 cos theta. Now the cos, we put cos where the angle is, so this will be T3 cos theta. That's how you resolve it. And then we're also going to resolve this into the x component and the y component. We're going to resolve T1 into the x component and the y component. So we write a line here. I hope what I'm doing is visible. So since the 35 degrees is here, this will be T1 sine 35. This will be T1 cos 35. So we put cos where the angle is. Now that we've resolved, we are going to equate forward forces to, backward forces to forward forces, upward forces to downward forces. Again here, forward forces to backward, upward forces to downward forces. Now, if you can see, the weight always points downwards, and here it's pointing downwards. But since this object is in static equilibrium, meaning this 40 is also here, so meaning here it's also 40 newtons. Here, since here it's 50, meaning here it's also what? 50 newtons. So now, let's solve for this part alone. Let's equate the backward forces to the forward. So we equate the backward to the forward force. So we equate T1 sine 35 will be equals to T2, the forward force, T2. Now, what's sine 35? Let's punch on the calculator. So sine 35 will be 0.574 T1 is equal to T2. So T2 is equals to 0.574 T1. So we'll make this one as our equation 1. Now let's equate the downward forces to the upward forces. So we'll get 40 newtons to T1 cos 35. So it will be T1 cos 35 is equal to 40. So what's cos 35? Cos 35 is 0.819 T1, which is equals to 40. So we divide by 0.819, also this side by 0.819. So this and this will cancel, and then 40 divided by 0.819, the answer will be 48.8. So T1 will be equal to, we'll just say 49 newtons. So we found T1. Now let's find T2 by putting this 49 here. So we write T2 is equal to 0.574 T1. So we'll get this equation 1, right? And then put 49 where there's T1. So it will be equal to 0.574 multiplied by 49. So 49 times 0.574, it will give us T2 will be 28.03 newtons. So found T1 and T2, right? So I'm sure we are done with this part. Now let's go to this other part. So I equated the backward forces, the backward force to the forward force, and then came up with this equation 1. I also equated the downward force to the upward force, came up with this equation, and it gave me the answer for T1. And then I replaced this T1 into the first equation, and then I found equation 2. Now let's see if we can find tension 3 under the theta. So now we are going to equate also the backward force, which is T2, to the forward force, which is T1 sine theta. So here it will be tension 2 is equals to T3 sine theta. T3 sine theta. What's tension 2? Tension 2, we found that it's 28.03, right? So 28.03, that's our tension 2 is equal to T3, we don't know, sine theta, we don't know. This will be our equation 1 for the other part. So we're also going to equate the upward force to the downward force. So it will be T3 cos theta is equal to 50 newtons, is equals to 50. That's our equation 2. Now, when you look at cos and sine, we know that we are under vectors when we divide, or let me say under trigonometry. Yeah, when we divide sine divided by cos, the answer is always tan, right? So now we are going to try and divide sine by cos so that we can have tan. So now what can we do here? So we are going to make T3 the subject of the formula here on equation 2. So it will be, so let me just say divide by cos theta, even here cos theta, this and this will cancel. T3 will be equal to 50 over cos theta. We are solving the two equations simultaneously by using substitution method. Now T3 is equals to this, right? So we are going to go on equation 1. Here on T3 we are going to replace with this one. So we write equation 1, which is 28.03 is equal to, now here our T3 we said it's 50 over cos theta, right? 50 over cos theta times sine theta. But we know sine divided by cos, it's tan, right? So this will be 28.03 is equals to 50 tan theta. Sine divided by cos, it's tan theta. Now we are going to divide by 50 so that we can make tan theta the subject of the formula. So here it will be tan theta is equal to 28.03 divided by 50. The answer is 0.5606. Now theta, when we take the tan to the other side, it will be tan inverse, right, of 0.5606. Now theta will be equal to shift tan inverse of 0.5606, which is giving us 29.3 degrees. So our theta, we found that it's 29.3 degrees. Now let's find T3 here. So we'll go back. Let me just write it here. Let me make a demarcation. So we write that equation, which is 28.03 is equal to T3 sine theta. Now our theta, we found that it's 29.3. So it will be 28.03 is equal to T3 sine 29.3. What's sine 29.3? Sine 29.3 is giving us 0.489 T3. So divide by 0.489, 0.489, this and this will cancel. Our T3 will be equal to, so 28.03 divided by 0.489, the answer is giving us 57.3 newtons. That's our T3. So now we found T1 as 49 newtons, T2 28.03 newtons, T3 57.3 newtons, and our theta is 29.3 newtons. So these are the solutions to that particular question of ours. So thank you very much.